Going over to Glacier National Park, we have an exercise where we're going to study the glaciers up there. This is the figure that we're going to use to answer the questions, as well as this one. This has a list of the glacial features that we need. And this one also gives us a basis for the listing of the features. So the question up here was list the features, right? So if you go through all these pictures and list all the features, you'll get a list like this, right? You see lateral moraines, that's the debris that's left on the side of the glaciers. Valley glaciers as opposed to the continental glaciers. Arêtes are the dramatic, beautiful mountain peaks in glacial areas. The cirques are the little bowls at the place where the glaciers initiated. Hanging valleys are side glaciers to come into the main ones. The tarns are erosional features from the glacier. The waterfalls, the U-shaped valleys. The terminus or the terminal moraines and the lateral moraines. So question B asked you to find this middle quartz lake, and notice that the patrol cabin is located between the lakes, infer the chain of geologic events that led to the formation of Quartz Lake, and the little piece of land that the patrol cabin's on. So you have to go back to this map here and see down here in the lower part of the map on this Quartz Lake. We're talking about Quartz Lake. So you got this lake, you got this little bit of land there. What is that thing? Well, that is a terminal moraine that acted as a dam when the glacier brought all its stuff down and piled it up there at the front of the glacier. It left a big mound of sediment. Then the glacier eroded or retreated and went away and left that pile of stuff there. The pile of stuff is called a terminal moraine. So the history of the thing was, well, there was a glacier, it filled the valley, the moraines came in, they deposited material, the glacier left, and that's why we got the little patrol cabin there. So that's your answer to B. Question C is based on your answers for this. What kind of glacier is it? Well, it's a mountain glacier. Then we have a question about the Continental Divide, and recall that it divides water going into the Pacific Ocean from water going into the Gulf of Mexico. Well, here it is on our little map. It says right there, Continental Divide. So that's think of ways that the Continental Divide may be related to weather and climate cycles. Recall that systems go from east to west. Okay. The weather patterns come from east to west. And if the weather pattern hits a mountain, it goes up over the mountain. And when it goes up, it cools down. When it cools down, it rains or snows. Continental divide is the high point of the middle of the continent. Okay. You get on the continental divide, you're going to go downhill to the east and downhill to the west. So what we have here is a huge climatic example of a rain shadow. Most of the precipitation that comes in from the storms that encroach on our beloved country from the Pacific and the Arctic and the equatorial Pacific, they dump most of their load of rain, water, and snow by the time they get to the continental divide.
Right, on the coastal sides, right?
On the side toward the coast, yeah. So, at any rate, so the reason that there are more glacial features on the west side of the continental divide is because that's where most of the snow is. Make sense? So west of the continental divide will be more snow, east it will be less. That's your solution to question D on page 273. D2. So down to D3. Look at the glaciers on the map area in relationship to the ridges. Do the glaciers tend to occur north, south, west, or east? And why is that? Well, if you look at this map closely, most of everything is trending here to the south. So the answer there is glaciers mostly occurred on the southwest side of the landforms. They're mainly between features that lay northwest and northeast, and the structural grain is due to the underlying geology. Structures may be faults and inclined beds. So our interest, I think, point of this exercise is to say that glacial erosion and glacial deposition is not only controlled by the amount of snow and ice, but by the character of the rock that it's on. Because some rocks erode more easily than others, and that structural lithologic variable will govern the position of glacial features. So going down to E, we got another data table for this glacier. And the glacier's in the northeast part of the map. So here's this glacier right there. What I did here is I just took this thing and I zoom in a little bit for you, so that you're not going to find some of these illustrations. See, you're not going to find in your text in your manual, because I create them for you in the slide PowerPoint file. So what I did is I just took the zoom in for the Agassiz Glacier and put the data here together. So you got 2 bits of information in order to answer the question. You can see how the data for the thing, another glacier here too, but it looks like the size of this thing decreased. Whoa, look at this, it increased a little bit. From 93 to 2005, it increased a little bit. But what you can say is that between 1850 and 2005, you subtract 204 from 406, and you can get, well, that's how much it was reduced. And now we do the same thing for this Vulture Glacier, which I show here zoomed in on that for you. And that one, that the data shows it went from 0.77 to 0.32. So that's more than a 50% decrease. This one is about a 3/4% decrease. Okay, these are on the same map. They're within a few miles of each other. One decreased by 75%, the other one decreased by 50%. Why are they not the same? Do you expect the area, what do you expect it to be in 2020? Well, you could be rigorous about it, I suppose, and plot it out on a graph and project it like we did in the earlier exercise, but I don't see a great value in that. So I will accept the answer of this generalization that, well, it looks like it's shrinking and may disappear. Goodbye, Agassiz and Vulture glaciers. Boo-hoo.